This lesson is about enzymes and activation energy. Here are your objectives. Let's start by thinking about firewood. Firewood has lots of energy trapped within it, and that energy is released when it catches fire. But it doesn't just catch fire on its own. You need to provide a spark to light it and get it going. You need to activate the process, and that spark that you're providing is giving activation energy to the wood, and then after that the reaction proceeds on its own. Thankfully, the same holds true for the tank of gas in your car. You need to provide activation energy to get it to combust. And that's also true for the reactions in the biological systems that we're interested in. Let's say that you have reactants that have an energy up here. I'll draw those as this molecule of two atoms joined together and this other molecule of two atoms joined together. And we want to react those to form products that have lower energy down here. So now one of the red atoms joins with one of the blue on each side. So this is our reaction. We're going from link this way, breaking that bond and breaking this bond, and forming bonds in that direction. Now, just like firewood and the burnt ash that's left over, here the reactants have more energy than the products. We see them higher in energy on the y-axis. And by the way, as you study this further, you'll see that this is really called free energy or Gibbs free energy. But you can think of it as the potential energy that's stored in the molecules. And that energy is lower in the products. So in a sense, this reaction wants to happen. In chemistry, you'd say that it is a spontaneous reaction, but that doesn't mean that it's going to happen quickly. Just like you needed to light the firewood, you need to provide some energy to get this reaction over this bump here. You can think of this as being the raise in energy that is given by the spark that you use to light the fire. The molecules need to gain that energy, and then after that, the reaction will occur on its own. This energy, the difference between the reactants and this highest point of energy, is called the activation energy. And what's happening there is that the molecules are being stressed and contorted so that bonds are starting to break. So you can think of these bonds as starting to break up here. And we call this the transition state. That's the state at the top here. So the activation energy is the difference between the energy of the reactants and the energy of the transition state. Once they get up here, the bonds will break and new bonds will form and will end up at the products. Now, where does this activation energy come from, the energy to get over this bump? Well, typically it comes from thermal energy, or energy of heat. We added thermal energy when we lit the fire. But you can't do that effectively in biological systems because A, if you apply too much thermal energy, then proteins will denature, and also it'll just increase the rate of all of the reactions, and you want to be able to do it selectively. So what enzymes do is they lower the activation energy. They lower the amount of, in this case, thermal energy that you'd need to add to get the molecules up to the transition state. So in the presence of an enzyme, the reaction looks more like this. So enzymes lower the activation energy. And they do that by a number of different mechanisms. They might stretch or contort the molecules that are breaking bonds and forming bonds. They might bring two different molecules close together. They have a variety of mechanisms, but all of them lower the activation energy. So here, again, in blue, that's without an enzyme, and in the red here, we've shown with an enzyme. Note what enzymes don't do. They don't change the energy of the reactants, and they don't change the energy of the products. So those remain the same. And in fact, in this reaction, we can see the energy of the reactants is higher than the energy of the products. So overall, there is energy released by this reaction. And enzymes aren't going to change the amount of energy released. They don't change the energy of the reactants or products, and so they don't change the energy released. But they do lower the activation energy. This particular reaction shows energy being released, and we call that an exergonic reaction. So here, again, here's an exergonic reaction. There's still a positive activation energy, but the energy of the products is higher than that of the reactant. So this releases energy, and we call it an exergonic reaction. In contrast, a reaction where the energy of the products is lower than the energy of the reactants, like this, is called an endergonic reaction. So that's an introduction to exergonic and endergonic reactions and the effect of enzymes on activation energy.